Welcome back to lesson 1.4. So in this video, we're going to go through the last two examples, which are special cases that we might encounter. Um, as we saw in the previous videos, we've been using the elimination method in order to solve systems of linear equations. So we're going to try this. This is example E or number 5, whichever you prefer. And we have our first equation as x plus 2y equals 4. Our next equation is 2x plus 4y equals 8. And so we're going to follow the same process. We're going to try and eliminate our x's. So in order to do that, we'll have to multiply the first equation by 2. Multiply by 2. And so when we do that, we'll get 2x plus 4y equals 8. And our other equation is also 2x plus 4y equals 8. So we can see we actually have the exact same equation. Um, so when we have the exact same equation, as we've seen in the graphing technique, same equation means same line, which means there's an infinite number of solutions available to this system because they're the same line and they'll actually overlap one another. But just to prove what happens, we will go through and we'll actually subtract the equations here just to prove a point about when we have infinite solutions. So 2x minus 2x is going to be 0. Our x's are eliminated. But 4y minus 4y is also going to give us 0. So I'm just going to put 0 on the left-hand side. Now, on the right-hand side, we've got 8 minus 8, which also equals 0. So what we're seeing here is this is actually true. 0 equals 0. So that tells us that this is the same line with an infinite number of solutions. And the reason I showed you this 0 equals 0 is because of what we'll see in the next example. It tells you when you'll have infinite solutions versus when you'll have no solution. So this one here, uh, whoops, sorry about that. Let's go back. This system has an infinite number of solutions. So when you go through the elimination process of your system and you get 0 equals 0, that tells you you have an infinite number of solutions. Now you may wonder why I showed you that when it was obvious that it was the same line. And the reason I'm going to do that is because of this next example, our final example in this lesson. We have 2x plus 3y equals 6, and our second equation is 2x plus 3y equals 4. So we can probably already look at this and see that there's a problem. We've got the exact same coefficients and variables in both equations, yet one equals 6 and one equals 4. So we're going to just subtract these. So if we do 2x minus 2x, our x's cancel out. 3y minus 3y, our y's cancel out. So we're left with 0 on the left. On the right, though, when we do 6 minus 4, we're left with 2. And we know that this can't actually be true. 0 cannot equal 2. So this system of linear equations is two lines with the same slope but different y-intercepts. So in other words, they are parallel lines. So you know it's parallel lines whenever you get that untrue statement. You eliminate all your variables and you get something like 0 equals 2. You know that can't be the case. That tells you that it's parallel lines, and this system has no solutions. Just once again, this one we get something that can't be true, like 0 equals 2. That tells us it's parallel lines with no solutions. Where the one above, we actually got a true statement, 0 equals 0. And that tells us that this system has an infinite number of solutions. So hopefully you're able to follow along with that. As always, though, if you have any questions, feel free to either join me on the live office hours or just send me an email and I will help you out. Once you're done lesson 1.4, don't forget you'll have the unit assignment to do as well. So good luck on that. And if you have any questions, please don't hesitate to contact me. Take care.